So what is a relation? Um, so in math, we have this idea of different domains, and these are just different sets. So let's say we have some domain um, A, B, C, let's say A, B, C, D, uh, and let's call this domain D1. We have another domain D2. Let's say that is 1, 2, 3. So these are two different sets, and we can have a relation um, that acts upon these two sets as a subset of the Cartesian product of these two. And what that means is, let's say we took the Cartesian product, d1 cross d2, and this is simply the combination of everything of all tuples where the first comes from D1 and the second tuple comes from D2. So this itself is also a set of tuples. And how many elements would be in this set? Well, you take all the tuples in D1, the number of tuples in D1, and then times the number of tuples in D2. So that's 4 times 3. So that's 12 tuples in total in this new set. So there's 12 tuples in this set. So let's enumerate all of them. So we can have the first element from D1, BA. And how many of those are there going to be? Well, there's one for each, one for 1, one for 2, and one for 3. So there's going to be 3 of those tuples. So A, A, and then there's going to be similarly B, and C, and D, right? So these are all the possible um, first elements in these tuples. And then we're just shortly going to enumerate all the second elements in these. So for A, we can have 1, 2, or 3. So let's write that. 1, 2, or 3. For B, we can have 1, 2, or 3. For C, we can have 1, 2, or 3. For D, we can have 1, 2, or 3. Right, so these are all the elements that we can have in our set. Right? Okay, so that enumerates all the elements in our set D1 cross D2. This is the Cartesian product. Let me change the color here. So this right here is called the Cartesian product. Okay, so Cartesian product is just every combination of D1 and D2. So where the first tuple is from D1, and then the second tuple is from D2. And enumerating all those possibilities and putting it in this set called D1 cross D2. That's the Cartesian product. But now relations are sort of a subset of this Cartesian product. So let's uh, let's actually show that. So a relation is a subset of Cartesian products. So for example, a relation here for this Cartesian product in particular um, might be, the subset with b comma 2, c comma 3, and a comma 3. That might be one Cartesian product, I mean subset of a Cartesian product that we can define as a relation. So a comma 3, b comma 2, and c comma 3. That's a relation, and it's totally valid. It's a subset of D1 cross D2, and in our case, this is how we defined this relation. So we took this particular subset and said this is the relation we're interested in. So anyway, that's the idea in general of relations in mathematics, and we'll see that it's pretty closely tied to database relations, relations in particular in a table, right? So let me also write down here um, in SQL, and SQL is the query language that we'll be looking at. In SQL, tables are representations. Oops. They're representations of relations. So you can kind of use these two terms sort of interchangeably. Relations are tables, and tables are representations of relations. Um, yeah,